My name is Ritchie. Hopefully I'll get to meet many of you during the day. I'll be here all day. And I am one of the software engineers here at Excella. And my presentation basically covers continuous integration, but I try and format it in three concepts. One is the blueprint, which is a way of sort of organizing what continuous integration is all about. And then I'll talk about the toolbox and things that go in that toolbox, give you a sense of that. And then the third is sort of the mastercraft. For those of you who are doing continuous integration, that's an opportunity maybe for us to dialogue on what you can do to sort of take your continuous integration to the next level, what that might mean in practical terms. At this point, I'd like to ask the question, how many people are using continuous integration in their projects right now? Okay.
How well we do it is a different question.
Well, hopefully you can get better at it. There are ways to improve it. We can talk about what those are. Just for those who are live tweeting, my handle is @ruthlesshelp because I'm ruthlessly helpful. Hopefully I'm more helpful than ruthless, but I like to try and think that I give the plain truth, the pragmatic truth, and focus on that. If you're looking for the slides, you'll find these slides are on SlideShare @ruthlesshelp. And you'll also find the code samples that I'm going to show up there with my presentations. There's a lot of code samples, so you may have to wait a little bit through, so I'll kind of key you into what I'm using as the code example. What I wanted to kind of start with is what the problem is that continuous integration solves. So if you're in a team dynamic, you've got source code here. Now, let's contrast what Sam and Mike were talking about earlier. What they were describing was a personal process. And continuous integration is really about a team process and trying to improve that. Okay? So if you have Scott makes a change from Scott's computer, they may get the latest source code and they may push the latest source code. And then Susan makes some change by pulling source code, pushing source code. You get that source code and it breaks. This is the essential continuous integration problem, or the essential problem that continuous integration is trying to solve. So here there is literally the left-hand developer of Scott not knowing what the right-hand developer of Susan is doing, and you are in the middle. So there are many things that can go wrong. So Scott or Susan might have conflicts in implementation. There may be missing files, right? Scott pushed his code but forgot to include everything. Everything builds on Scott's machine, not a problem. And then there are breaking changes, things that impact everybody else. And only Scott has resolved the problem on his environment and inflicted these breaking changes on everybody else. So how do you find integration issues? I want to give you guys, everybody, a chance to think about this for a second. If you are the developer who is pulling Scott and Susan's code manually right now, what are some of the things that you do to deal with these integration issues? Anybody have any suggestions? One of the things that I would do is I would rebuild once I pulled, right? What are some of the other things you might do?
Run unit tests.
You might what?
Run unit tests.
Run unit tests. Very good. Right?
Check the version history comments for what they checked in.
That's right. You can see what's been happening.
I would send a zip file to them and tell them to
There you go.
send me another zip
You get on the phone and you say, fix your problems and check them back in. Very good. Notification, we'll call that. Right? I remember when I do, without continuous integration, as a team lead, one of the things that I used to do every morning, I come in, first person in the morning, start with a clean folder, get the latest, build everything from the beginning to the end. I would follow my little sheet of paper. I would run unit tests or whatever, automated tests or whatever tests. Some of them wouldn't run because the configuration I didn't know or what have you. But ultimately, as the team lead, I had to deal with this. I dealt with it early in the morning because I used to deal with it late on Friday. And I would find myself not getting home very early. Okay? So integration issues as a team process can be very problematic. They can be very time consuming, and they usually hit one person. Often that one or two people are the ones that are trying to be most careful and thorough. They get punished because they're always trying to figure out what's going wrong with it. Somebody else might not care. So your manual integration involves maybe a build, you're going to run some unit tests, perform static analysis. How many of you are performing static code analysis right now? Okay. So static code analysis is a tool that's going to look at your code and look for things like guidelines not being followed or best practices not being followed. It's going to do your look for things in your code which you might find says this is a problem. And then you might have to do a clean and rebuild all. Right? Those are when the things get really problematic. You know, you get something that you can't figure out, you just say, okay, I got to put all that code aside, start from an empty folder, and build everything from the beginning. So here is the blueprint for continuous integration. Adding a continuous integration server that links up to your source control. So what the continuous integration server is fundamentally going to do is it's going to look for and be triggered by a code change. So when Scott puts his code in, the continuous integration server is going to create a clean folder, pull all the source code down, rebuild everything, and if something breaks, it's going to send out a notification. Maybe it'll text message them in their home when they're sleeping and wake them up, hopefully. But you're going to be able to maybe reach out and touch them through this server, right? All of the other things I mentioned. Unit tests, run all the unit tests. Run static code analysis. Put all these things together so the team lead doesn't have to. So when Scott checks in the code and is forgetting 4 files that were supposed to be added, continuous integration server breaks, you also know, I don't want to get the latest until Scott fixes it. So you don't have to deal with the problem because you're notified about the problem before it happens. There are 2 things that are very important to get continuous integration really working well. One is it has to be triggered by your source control management system. Right? You could have it run every 15 minutes. You could do that type of thing. The problem is that if Susan and Scott push something together, it's going to be hard to sort out who did what. And in teams that are very large or that geographically distributed, that can get kind of tricky. So you really would rather have it trigger a build by that. Now some will have hooks into the source control, and some will poll the source control pretty frequently. But either way, you want the change to trigger rather than having a time trigger. The other key is an automated build. And I see too many groups trying to get continuous integration working without having figured out already how to do the automated build. So, a prerequisite is to figure out how to script that, how to run that. It takes a little bit upfront time, but that will make the whole process far more successful. So, I'm going to start referring to continuous integration just by CI, partly because it's a little bit of a mouthful. The other thing is that it's just commonly known as CI. So you'll hear CI server. So these are typically referred to as per commit steps. So every time somebody commits a code change, you'll go through this. Now, at the bottom of the analysis, I have two things that are just examples of the types of analysis that you would use. There are more analysis that you can add in to this. Some of the other analysis is duplicate finders. Go find how they look for big blocks of duplicated code. Maybe too much duplicated code is an early warning sign that a developer is just copying and pasting and doing something that might introduce some bugs. You may want to be notified. Okay? Notice how I say run all unit tests. The reason I say run all unit tests is because most of us developers run our unit tests. Now, if I make a change that breaks Susan's code, then what happens is that I probably didn't run Susan's unit tests. Because hopefully Susan's unit tests would have said, look, your change broke my code. I was expecting something. So a key element here is to run all unit tests, and that's what I mean by a team process. So you might have an individual process. Hopefully you're at an individual level, you're running all the unit tests that you can, right? But at the very least, your CI server is taking care of that for you. So now everybody has a sense of what the blueprint looks like. You're simply going to have this box that acts like a team lead developer, get latest, clean to a clean folder, rebuild everything, run all the unit tests, and do some code analysis. The question is, what do you want to do? How do you want to do that? And I'm going to present some examples of these servers. The first one is a server known as Jenkins. It has a couple of virtues, free and open source. It's very commonly used in the Java world. Right now I'm using it on a .NET project, so there are .NET plugins. There are lots of benefits of using Jenkins that come out of the fact that it is widely used and widely enhanced with plugins and other support. So it's a good choice. If you want to leave here today, starting Monday, you walk in and say, I want to do something on my Java project with Jenkins, you're going to find that's a fairly straightforward process. Mostly it's going to be finding the machine that you want to do this on and getting it to connect to your source control system. That's going to be most of your job. This is cruise control, and cruise control is the old school, I will call it, for lack of a better word, but it was one of the early continuous integration servers that was widely adopted. Again, it's free and open source, and the fact that it's been around for a long time means that it's going to be well supported. You're going to be able to Google your question and get good answers and good examples. The thing that I do not like about cruise control, and cruise control, by the way, has a brother and a sister here. There is the Java version, which is up on top, or the one below it, which is the .NET version. It's very XML heavy. There are a lot of XML configuration files. Something like Jenkins is very browser-hosted interface friendly and browser-hosted administration friendly. But if you feel like old school is what you want and that type of thing. So I'm not a big advocate of cruise control, but when I started doing continuous integration many years ago, that's where I started, so I want to put that right there. Second of all is some of you may have cruise control at your disposal right now and just feel like it isn't getting engaged, and that's why I also want to put it up here. The third option is a product called Team City. So as I was putting together this presentation, I asked myself, how many commercial products do I really want to talk about? Right? And what I realized is a lot of those vendors would really want to talk about them to you. So you won't have a hard time getting Microsoft to talk to you about their .NET solution, or Oracle to talk about Hudson, right? But what I wanted to do is give you an option for something you could get started free today that shows you the potential of a commercial solution. And I think TeamCity is a good example of that. It has what's called a professional version, which is free. It's closed source, it's a commercial product, but it's free for the professional version, which will support up to 20 configurations. And without getting too deep into what configurations are and other limitations, there are limits on the agents and stuff like that. If your team, your development team, your project wants to get started with continuous integration and you think eventually as we get big, we will go enterprise-wide with this, TeamCity is a great option for you. The second thing is that for both Java and for .NET, it is very progressive, leading edge on a lot of the technologies. So a lot of what you want to do in continuous integration on the leading edge, you'll find that. If you're in Jenkins trying to do .NET, you might find plugins to support what you want to do, or you might not find plugins to support. So I'm often recommending TeamCity, and I often go out there, demo it, and advocate for it, because at zero cost of entry, it's often a good choice. Okay. So I'm going to switch over and do a little bit of live demo. This is probably a good point to see if anybody has any questions. Sure. I can't hear you. Is it not good for PHP shops? I don't know. I don't know. Yeah, for Java and .NET, I don't know about PHP. Does anybody here use TeamCity or continuous integration in the PHP shop? What? Bamboo? I think TeamCity has Bamboo support, but I'm not sure. We can take a look at that at the open space. That's a great question
As
for
long
open.
as you can use Leiningen or Farm or whatever it is,
Right.
TeamCity should get it. Well, what it is that you
Right, so how you automate the build is crucial. So if you can automate the build, TeamCity probably can do that job for you. So that's the great question there is, how do I automate my build so TeamCity can use it?
Yeah, Google did and says that the Jenkins has PHP continuous integration support, so that's one of the
So TeamCity, as a commercial product, seems to cover the most breadth and depth, which is why I'm often recommended. Okay, I will start off by just introducing this project here. It's a little demo project that I built in .NET, and what we're going to learn about it so far is that it's just a project in .NET, and that's really where we're going to leave it. I give it as an example on my presentation, but you don't really need to focus on what it is and what it's all about. What I want to show you is that it has a couple of things that are going to be important as we move along in this presentation. The thing is, it has a couple of unit test projects over here, and it has a couple of different components. So it's a multi-component project. what I'm going to show you now is Team City. And I've created a simple pipeline for Team City. What you'll see is I've just created 3 number steps. I'm going to be rebuilding it, I'm going to be testing it, and then I'm going to be analyzing it. Okay? And so in Team City, what I do is if I want to create a project, I have ways to find different projects that I have. And for those that are in the administrative role, I can go in the administration. And one thing that I can do, see if I usually don't keep it this magnified, so I can create a project. I start to name my project, so everything leads me through wizard type of approach. I won't get into that in this presentation, but I wanted to give you a sense of what it's like to administrate. I click through on my rebuilding here, and I can see that I have 9 projects, 9 builds that have happened in the past. If I would like to be able to do, I can click run and start the running process. But let me show you where the configuration is at this point. So Team City allows me to connect to version control. And here in my version control, I have several different options. So I select the one that's appropriate to me. In this particular example, I'm using Git. And I will have 1 or more build steps. So in my build steps, I can do any of a number of build step actions. Okay? I could run a command line program. Or I could run, let's see, a Maven script, IntelliJ project, any of a number of different things. And within my project, I have more settings on when does the build actually fail and what triggers a build. In this particular case, the rebuilding is triggered by a version control system trigger. So what it's going to happen is, let's see if I can zoom in just a little bit more. When the version control system experiences a check-in, it's going to trigger one build, and it's going to allow 20 seconds for that developer to maybe check in a couple more times. I could extend that. I could also do some things because it's smart enough to say, let me get everything that Scott does and let's put all that together. And let's get everything that Susan does and let's put that all together. So that if we have subsequent check-ins, we can organize them together. Yes?
Each check-in would reset the white period timer?
Yes. Yeah. Yeah. So if I'm in the activity of checking in, often it's like 60 seconds, it could be 120 seconds. So every time I do a check-in, it waits for it to go quiet again for another 120 seconds. Okay. So let's actually see this in action. I am going to start with a little dummy event here. I'm just going to add in a repeat of this. Maybe I'll make note of the fact that this is happening at DC Agile Engineering Conference 12. So I've made that change, and let's go ahead and commit that change. Okay. And once that's successfully committed, we're going to wait right here. Now, hopefully, there's no problem. Drum roll, please. Oh, there we go. It detected that there's a pending change, right? So now it's in its quiet period. It's going to wait, see if anything else happens. And at the next interval, when it comes around time, it will start rebuilding. And I can configure it to rebuild from a clean folder, or in some very large projects, you might not want to pull down everything to start the process. Okay, so now it's going to pull in my 18.83 megabytes of repository data and bring all that down. Now at the very bottom here, there's a little piece of what's sometimes referred to as toast that pops up, okay? Like Outlook and such. And this just told me that that build happened successfully. So if I'm another developer on the team, I can get a little notification when somebody else does a build, right? I can also configure it to email me or to message me or whatever other options I want. The second thing it's going to do is it's going to start to run the tests. Not just the tests, but every test that I configure it to run. So if I have 7 test modules, unit test modules, I can run all 7 of them. Give me another piece of toast pop up. Let me know that happened okay. And then the third thing it's going to do is it's going to analyze my code. And let me know that that happened correctly. Okay. So it appears to be working okay. First embarrassing moment avoided. So let's talk about what Scott's been assigned to do. Scott's been given some to-dos here. He's been asked to add a parameter. To each of these methods. Okay? So, Scott just made all those changes. Great. That was what he was asked to do. Go into the files, push the changes, and then Scott is going to commit them. So he made the changes he was asked to make, right? Go into the file and make the changes. Okay. Let's see how Team City is going to react to this change. Okay, so what did Scott do? Scott made a breaking change to an interface and didn't care about the consequences. Didn't rebuild, didn't see if anybody would be impacted, just made those changes. So we're going to get the pending change come up. And at this point, we'll pretend that I'm Scott. And Scott is not ruthlessly helpful. He's ruthlessly careless. So we're going to start building. And we get a compilation failure. Boom. Down here, there's a notification. There's also an icon down here. Hopefully you saw it. It's a green checkbox. It's gone red now. You can set it up to email you. Right? You can have it set to send a text message to Scott. Right? I have even heard that there is an organization that has a little dart gun that will find Scott and fire a projectile at Scott. if Scott breaks the build, right? So Scott broke the build, but I'm the team lead. What do I know about this? Well, I know the compilation failed because I saw the toast pop up, right? But I don't know who did it. Do I? Well, let's take a look at the changes. The changes associated with my name, version control system username, Stephen.Ritchie. All right? And what's the comment say? Comment says, made the changes you asked me to make. That's not very helpful, right? So how can I drill down in here? I can expand all the information it has, and I can go in there, and I can say, oh, okay. We have an interface. Scott made the change to the interface. We didn't make any other changes. That is the power of something like TeamCity, continuous integration. It's putting all of these pieces together and running them continuously in a way that manually you just either didn't have the time to be so thorough with, or all the pieces didn't integrate well and you couldn't connect who's doing what, when. The left hand is over here, the right hand's over there. People are disconnected in time, people are disconnected in space. Someone's working on it at 2 a.m., somebody's coming in at 6 a.m. This continuous integration server is bringing that problem prevention right out in front. And it's saying, it is behaving like the most careful and thorough developer on your team. Finding problems, alerting people to those problems, etc. Okay, let's get back to business here, and let's unfortunately, I have to keep taking my glasses off and my glasses on, so at one point, I'm not going to see any of you people, and then I'll see you all again. They say bifocals could work, but I'm just a little reluctant to get those things. So let's go back and undo these changes. I don't have an easy way to undo these, but so I've removed Scott's changes, and I'm going to go ahead and commit them. Okay, in the meantime, I am going to be Susan for a little while. And Susan is going to help here, because Susan thinks that she found a problem. And she thinks this equal sign does not belong here. So she's going to correct what she believes is the problem. Now, she's not being careless or thoughtless. She just doesn't understand that there's going to change a requirement, right? So there's nothing, she's doing everything right. So we're going to take a look at what's happened in our pipeline here. We still have some pending changes, so I'm going to let those work their way through the system. And we'll give that just a little bit longer. Fortunately, these are running only a few seconds. In some build processes, these will take longer. So everybody should be appreciative of the fact that these aren't running for 50 seconds. But at the same time, TeamCity is designed, and most build integration servers should be designed around the idea that you have a relatively fast pipeline. People always ask me, what's a fast pipeline? Say, well, imagine you're trying to go home on a Friday night. Right? How long are you willing to wait to see that something goes through the pipeline its entirety? 5 minutes, 10 minutes, 30 minutes, an hour? You know, as you get longer and longer pipelines, you're going to have people more and more reluctant to wait until it's done. So they'll just push code and leave. But if you get it short enough, it will be okay to say, okay, if you push something at 4:30, you got to watch and make sure it's completely done. Okay, so that has happened. And now we are going to commit Susan's change. And at this point, they'll detect that Susan change doesn't break the build, right? It'll rebuild, everything will be fine. So how do we know that there's a problem? Well, hopefully our unit tests test that condition, that equality condition, right? And this is why something like TDD becomes important, is that if TDD is a reflection of what the code is intended to do, then those unit tests help make sure that it continues to do what it's intended to do. If it's not doing what it's supposed to be doing, you should start getting a notice. And we get our notification that the build worked fine, Susan did a good job, maybe making sure that everything rebuilt correctly before she checked it in. Now we're pending our tests. And at this point, it starts running. It doesn't take it long. And yes, it failed. Okay? So we're getting notification that 3 tests have failed. Now it sends out a notification to everybody that it's failed. Again, as the team lead, I would come in here and I would say, hey, what went wrong? It was green before. We've got 3 tests failing now. What do I want to do about that? Well, I could drill into the test and examine it. Examine the results. I could also go over and look at the changes. I see that this is Susan, remember, not Stephen. That Susan checked something in. I can expand it all. I could take a look at that and say, oh, I see. We had that line changed. Let's go talk to Susan about the requirement change. Okay. I ran through, corrected the problem, the tests have gone through, and everything is back in order. Okay, now I'm going to introduce one more thing, which is, I don't know what this character's name is going to be. We'll call him Mischievous Mike, okay? Mischievous Mike likes to add in variables that aren't really necessary. These are, because if 3 variables are good, then 30 must be better. So in our pipeline, in the analysis, we have something called a static code analysis. In the .NET world, it's called FXCOP. It stands for Framework COP. And what this is going to find is this problem. So at this point, I could go through and I could do a rebuild of everything. I won't find this problem. I could go through and I could run all my unit tests. Let's see if I can run all my unit tests. If I could run all my unit tests, then I wouldn't see this problem. But thankfully, I have an integration server. see. Once I commit those changes to Git, we'll start getting this to run again. And before it actually hits that stuff, anybody having trouble seeing this, by the way? Is this too small a font? You having a little trouble? Okay. What FXComp is going to do is it's going to report some two numbers here. They're called inspections by TeamCity. And one is the number of errors it's found. And there are 25 errors that it's found. The other is the number of warnings, which is 52. So many people would say, well, you really should have 0 errors, right, Stephen? And you shouldn't have 52 warnings. Well, many of your projects, if you ran a static code analysis through to today, you might get a lot of errors and a lot of warnings you don't have time to remediate. And so what I've done is I've configured my analysis with thresholds. Because if I get more than 25 errors, then we want to fail. And if my warnings goes above, let's say 100, then I want it to fail. So essentially, if at any point people are going to double what we've had in terms of warnings, or they're going to introduce errors, I want to know about it right away. Third demo scenario went successfully. I get the error and the little toast pop-up telling me that there's an error. Let me slide that up a little bit. So my number of inspection warnings is too large. It's 128, and I know my threshold is 100. So I can pop in there again. I can take a look at the details of this. I can see who made the changes. I can expand those changes. I can pull in there and say, whoa, what's going on here? Somebody just uncommented a whole bunch of things, but it wouldn't look like it was uncommented. It'll look like they were added, right? So there's how the analysis. This type of analysis can be done with static code analysis, which does an investigation of code quality, best practices, security guidelines, find duplicates, violating coding standards, whatever a team process defines as something that should happen. Now, it can't do things like code review your code, right? But it can do a lot of things that are very helpful in these tools. And it can define some thresholds. And there's a lot of different ways to configure it to follow sort of mandatory guidelines where you'll break the build, and do some voluntary guidelines where you'd like everybody to do a better job with this coding standard, but it's not really a showstopper. But maybe this other coding standard, like, you know, you might have a coding standard that says the one-letter variable name, you know, integer x. Let's not do that anymore. Let's have a rule that basically says, you know, I've seen too many things where there's an array of x, right, with 23 dimensions or whatever, and you're sort of sitting there going, let's see if we can come up with a coding standard that prevents that from happening. So those are the kinds of things you can put into the analyzing step. Now, there was our example. And I noticed that with the break and everything, I'm going to be running close to my allotted time here. Let's take a look real quickly at the master craft. So adding unit tests are great. Adding code coverage, which is a tool that will look at as your unit tests run and figure out how much of the code is actually tested by that. So it can tell you the number of classes, the number of methods, the number of lines, the number of branches, and it essentially gives you a measure of how much of your code is being tested by your unit tests. That's a great way to add in to your continuous integration process. You can add in system testing, integration testing, and acceptance testing. At one client site, what we did was every night we would schedule a continuous integration task that would install the latest code onto a server and then kick off a whole suite of automated system tests. And in the morning, when it was supposed to be done, Team City would pull that HTML report and let it be displayed. So a project manager could come in and look at last night's system test results. Right? So Team City becomes a hub for some of these types of activities and results. Code quality analysis, things like cyclomatic complexity, other measures of code quality, of which I'm certainly not an expert, but I have worked with these tools enough to know some of the key things that you will want to get into. I think cyclomatic complexity, maximum cyclomatic complexity, is probably one of the most common things that I see people working on, is because they want to try and lower the complexity of their code. So I've kind of combined three thoughts here, right? How do you visualize the data? So you might want to see the number of tests growing over time. So a lot of these have charting tools to let you see that. And then the thresholds, right? So if your warnings go above 100, I want to break the build. Or if some critical code quality measure gives you a way to add that in. The last thing is reporting and visibility. As you can see, I have a lot of visibility into what's being checked in, what changed, who did it. I have a sort of a central control there. Also, I encourage a lot of project managers, team leads, and others, once we have, the team has this humming, as a great way for them to see what we're doing. Give them a login and say, we've been doing pretty well with this. How do I know? Let me show you. I'll show you the number of tests we've been doing. I'll show you our code coverage. We started with 17% of our code being covered by tests. Now we're at 47% of our code being covered by tests. We started with 300 warnings. We're down to 30. All of these things bring project managers into the process of what are you doing with all that talk of refactoring and TDD? What does any of that mean? You start to give them visibility into that. And then the last thing is packaging and deploying. If you want to deploy something in a reliable way, you package it up. You either zip it, you put it into some installable file, you use some other tool to give you that deployment thing. What starts to happen is that by packaging it well and deploying it through something like Team City, you can start involving your QA lead. They say, I want to get the latest build and install it on the server. Okay, let's go to Team City and let me show you how. Right? I just installed that one. That's worse than the one I had yesterday. I want to go back to the one that yesterday. Let's go to Team City and let me show you how. Because we packaged that one up yesterday. So all we have to go is tell Team City which one we want to deploy, which build number we want to put. You want to build 37? You want to deploy 37 instead of 38? Let's put that number in here. Let's click the run button. Boom, let's deploy that. So the master craft here is you're starting to go to your QA lead and say, don't come to the developers to deploy these things. We package them all up for you. We give you a central server for you to define which ones you want. And we give you a way, push button, deploy it yourself. These change things dramatically. I'll give you one illustration. I was on a project where the developers took some 30, 40 minutes to manually deploy to the test environment. We put it into Team City. We deployed in, I think it was like 30 seconds. Say, wait, why is it different? They had 10 manual steps they had to follow, right? They were running from their development environment out to the test environment. TeamCity was at the gigabit backbone next to that server. And it was configured to only deploy the files that had changed. So it could deploy like that. These things make a huge difference. Can you imagine the 2 developers that were deploying now never having to deploy again, never having to interrupt their day, spend 30, 40 minutes deploying? And guess what? There were manual steps they often misconfigured. Oh, I forgot to change that connection string. So it does it automatically and consistently, credibility goes up. That is my presentation. That is the continuous integration story. Does anybody have any questions? Yes?
I saw the way you were flipping through it the first time, there's an option for detecting hung builds.
Yes.
Yep. And this may be like too broad of a question, but what kind of things like causes building?
Okay, I was just talking to somebody the other day about their hanging builds, right? Somebody goes and they start running the build and they go, oh, I forgot to do something, let me go up and cancel that build, right? And somebody else has got a build going and they're going up and they're saying, oh, let me cancel my build, right? And so there are these multiple agents, build agents, running multiple people's build, and they just start getting pumped, right? And they're just spinning their wheels. Well, how does TeamCity know it? It's because it's communicating with his agent, and the agent is just like not talking back. And at that point, it's like, hey, this agent just got hung up. Okay? So whatever reason the agents aren't either, maybe they're waiting on source control, or they're just something's hanging them up. Or maybe people are doing things that are just getting them into a lockstep.
What's the recovery process?
So usually agents can be restarted, and from the agents, through the interface, you can restart the agents, and sometimes the agents can restart the machine that you're sitting on. So if you have larger applications. I will tell you, I only see this in enterprise TeamCity configurations, so it's usually not a problem. Small team dynamics, you usually don't need a lot of agents. You don't need a farm of build servers, but you can have build servers each with different configurations. You could have a Linux one, you could have a Windows one, you could have a variety of different configurations, and each agent has its own capability and that type of thing. Typically, that's not what you want to start out with. The professional edition only gives you 3 agents. The enterprise edition is where you buy more and go bigger and bigger. Any other questions? Yes.
For example, like we have 4 projects and we have 4 different branches from each project which are being merged and packaged, and it's being put on say staging. And while testing there, and we find some issues, like how easy it will be for on the QA side, like basically independently be able to take out the branch from that package thing, or only the dev has to do that.
Okay, so if I understand the question correctly, it's how easy would it be for QA to figure out, I'm not sure.
How to take a part of the merged branches from the package.
Okay, so most continuous integration servers have an idea called an artifact. And so what will happen is when you package something up, that will be an artifact you can download through the browser-hosted interface. I will be available at the open source, open space, and I can answer and show you that directly. But what it does is it allows, through a tool like TeamCity or any continuous integration server that has this feature, you can go up and you can pull down and download the package. So let's say you would say, you'll need to install framework A plus module B and plus UI C, and install all 3 of them, or have DevOps do that for you, right? What you would essentially do is point them to those different links, say pull the artifacts from each and install each one of them. So it's actually very straightforward. It becomes sort of a central repository for those types of artifacts. Yes?
Can it analyze any kind of code like Python?
I don't know all the tools that it has available to it, but it's very .NET and Java friendly, which is what I'm most familiar with. any command line tool that you want to run, and I've done this in the past, that has an output, like an XML output, you can analyze that XML, or if it has HTML, you can actually display the HTML. So it depends on whether you're trying to run the analysis tool just so you can see the results, which it can display the HTML very straightforwardly, or you're trying to look at the output, and you're trying to think. So I would, to investigate this, one is I look to see if it has support built in. I have not looked that up. They have plugins. So many of these things, whether it's Jenkins or TeamCity, have plugins. And then the third is, even if there aren't any plugins, as long as the output can be evaluated, TeamCity or these other tools can then use that to decide whether the build thing. And for example, I've used XPath to go in and find out a sum of violations, and if the sum of violations was greater than 100, I failed the build. Yes?
So how it usually is easy to change the environment? Like you need to deploy QA, or maybe you need to deploy bad environment, practice. So how easy to do that?
So to use TeamCity to deploy, is that the question? Yeah. That is a question I am going to leave till the continuous delivery folks, because the mastercraft here is really a preview of where you want to be, and the ultimate goal is something called continuous delivery, right? Which is what you're describing. But it is something that I've done and I've been involved in on several projects, and it is a great place to be, where it automatically deploys out to the environment. But it doesn't start today. It starts today, and it takes some time, and it depends on the application. Yes?
Can you also integrate, say, the enhancements of bugs as part of the build?
So can you integrate enhancements and bug fixes as part of the build? Certainly, yeah. There are ways to connect these applications together so that, for example, you have a Jira application with the bug tracking. Most of that happens through the version control system, but that's a great question. I realize I am running over, so yes, I'll take one more question.
Yes. So what sort of tools or solutions do you know of for continuous integration involving the database? You know, Build 37 might require the schema of the database to be different than this currently.
Okay, that is a great continuous delivery question. I can give you hints on being in the open spaces, but that's a great question.
Does that fall under the category of continuous deployment instead of integration?
It depends. I would say that because typically what you're doing is you're going to deploy the application so that it can talk to that database. You're usually at that point where you're trying to find a way to deliver it to an integration environment. So it's really on that cusp. So automated integration testing and system testing, there's a gray line in there, but it's something I've been doing on a couple of projects now, so I've had to face this issue. So I'd be happy to talk to you about it. I just want to be sensitive to the schedule and agenda. Well, thank you, everybody. I appreciate your time.